Hey, good morning, everybody. Sorry I can't make class again today. The car's still sick and it's expensive and blah, blah, blah. I will be there after Thanksgiving on Monday, and we'll have a regular full class. But I didn't want to leave you all hanging. I know how exciting astronomy is to all of you. So I'm going to put together a couple of more charts here, a couple more little videos about certain aspects of things we need to cover. And this is where we are. So this is the unit we're on right now. We've been talking about these. We've talked about Kepler's laws. Some of you have done some labs on this. Woohoo, very good. Appreciate that. Now, something I've not got here right now is your next homework assignment. This will be another homework assignment out of the textbook on chapters 8, 9, and 10. Mainly some chapter 10 stuff with a little bit of chapter 9, not too much chapter 8. Don't worry about it. You'll understand when you see it. Now, I've given you an assignment on living on Mars, which was to do with how somebody that might be a Martian colonist or something like that, like we are talking about now in the news, might live on Mars. Also, I have some charts here on Venus, which I want to go over right now. And then after I finish that, I'll make another little video where we'll talk about some charts on Mars that I put together. Some of these are from the old textbook. I apologize because I like the pictures better. And then these are from on Venus and Mars, and this will go over some as well. These are all have to do with the surface and surface temperature of Mars, things like that, things that are important. And I may leave you with some questions about that. But before I do that, we're going to talk about Venus. Now, for me to do what I want to do, I want to stop the recording here just for a second, change the background, and we'll come right back. Okay, everybody, here I'm back, and I changed the background, and you will see in a minute I changed the background. What I'm going to do now is I'm going to probably just take my picture off. I know my picture is gone, and you'll see just some slides of Venus for the balance of the recording, but I will still be there talking to you. Okay, let's see. Did I really do that? I don't know, we'll find out. Anyway, so here's our little picture of Venus. I believe this is a composition of a compilation of pictures, photographs from different probes and things. As you can see, I wouldn't call it a particularly beautiful planet. It's kind of ugly when you look at it because of its makeup and temperature. The surface of Venus is pretty smooth because it's got a lot of atmosphere to it, pretty soupy atmosphere. There is no ocean on Venus because there is nothing like that. But it has some, as you'll see in a minute, it has a fairly smooth surface, but it has two big lumps in it that are two continent-sized features. And they have interesting names. They're Ishtar Terra and Aphrodite Terra. I'm not quite sure where those names came from. I've not looked for that. Now, one of the things about Venus that's very different from the Earth, and this is important, there are no plate tectonics. If you recall from our discussion of Earth on plate tectonics, that's an indication of a very volatile interior of the planet that has a lot of volcanism going on. There is some volcanism. There's some large volcanoes on Venus, but it's a different origin. So there's no, that we're aware of at least, no interior high energy system. And there's very little, if I remember correctly, there's very little magnetic field. That's important for life. I may wait to discuss that when I get back next Monday after the holidays. So here's these are mosaics of Venus, and it's important to understand this. These are pictures that do show some of the two main structures of the geology. And if you can't see because of my picture, although I intended to move it over here. I don't know if you can see that or not because I intended to take that off, but I don't know if it actually did it or not. Okay. So anyway, these are mosaics that are made of various images of the planet that are put together by computer. Now, this right here is something you'll be aware of. This is not real. There really is structure up there. It's just when the composition was put together, they didn't have images there. So there's no hole in the top of Venus. Okay, now these are the two major structural or geographic structures on Venus. Again, this is not ocean, this is just flatter land. Okay, now this isn't a great picture because they didn't have any great pictures of this area, but these are the two areas. This Ishtar Aphrodite and Aphrodite Terra, and all they are, they're regions of a lot of volcanic material and a lot of volcanic structure, and there is more structure here than there is other places on Venus. So I just found that interesting that we can see that. But again, there's no ocean on Venus at all. Here are the Ishtar Terra. It's one of the two continent-sized features on Venus. They're very, very large, as you can tell. But beyond that, there's nothing really. I'll probably hate myself for saying this. There's nothing really extraordinary about them. Good. There's nothing really. I'll make sure about my time. There's nothing really extraordinary about them, but there are large volcanoes and large impact craters too that exist on the surface of Venus. Here are some other areas around Aphrodite Terra. Indications of lava flow. Now, one of the things I want to point out here, there are what are called shield volcanoes here, and they just have a different type. These look like the kinds when you were in grade school that you made up and lava would flow out and flow over, because I believe the name really comes from the lava comes out and flows over this. It kind of makes a shield, old Viking shield looking thing, and I think that's where the name comes from. I'm not really sure, but that's a good line. Now this is interesting here, and this is nothing more sociology than it has anything else. There are impact craters on Mars. Everything has an impact crater on it because there's lots of asteroids and meteors. The largest impact crater on Mars is named after Margaret Mead, whom you may not have heard of. Margaret Mead was a sociologist or anthropologist in the 20th century. She was old when I was a kid, but because Venus has been, the planet Venus has been given the name of a mythical god that was feminine, they decided, whoever they are, to name a lot of the features with female names. This was done a long time ago. So you'll see more names that have women's historical figures, names in them when they've named for things on Venus and perhaps other objects. Now, these are some pictures of the surface of Venus taken from the Venera landers. And the landers were actually sent to Venus in the 1970s by the Soviet Union. They got there first. They didn't last very long. I don't recall if we've sent much of anything to land on Venus, but they sent them on. This looks very, very harsh, and it is. These do not last very long because of the high temperatures and a lot of nasty material inside the atmosphere. It's very hard for any kind of an object or a space robot to survive there. It's a very harsh environment. Now, these are some of my favorite pictures, and that's why I wanted to show you these. Venus's atmosphere is a very, very dense atmosphere. It has a very solid cloud bank that's 50 to 70 kilometers above the surface. The low atmosphere has got a lot of carbon dioxide in it because of the heat, and the clouds are made up of sulfuric acid. Doesn't that sound lovely? Now, here's some interesting numbers here, and we just got to get familiar with the units. This is the pressure, air pressure on the atmosphere of Venus, and you'll see some big differences between this and on the Earth, things like that. This distance here, this is the altitude above the mean diameter of Venus. So this is what you kind of see as something like sea level on the Earth, but again, there's no ocean. So here is 0. Remember this blue line here. This blue line tells us about what the average temperature on the surface is. Now, remember last week when we went over a long time about discussing what the meaning of different temperatures were, and we said 300 degrees, that is about the temperature room temperature on a nice day. 300 degrees Kelvin is about 75 degrees Fahrenheit. Okay, look how hot it is on Venus. It's almost 800 degrees Kelvin. I don't even want to think about hot days in Fahrenheit. You guys can calculate that for me sometime. Tell me what that is. But there isn't that much sunlight because of this sulfuric acid haze, and the pressure here is quite high. This 1 atmosphere, when you say 1 bar, that means the same thing as 1 atmosphere on the Earth. This would be the air pressure at sea level on the Earth. By the time it gets down, this is at 50 kilometers up. By the time it gets down to the surface of Venus, it's 90 bars. That's almost 90 times the pressure of the air on Venus on its surface. That's incredible difference. So that's another reason that devices don't last very long there, because it's like being at the bottom of the ocean. You gotta have a space submarine to get there to see it and survive anything. Okay, here's some more differences here, and I get tired of these comparisons with the Earth because there is no comparison. But this is why, or one reason, Venus is so hot. So here is the cloud layer, which consists of a lot of sulfuric acid. So you get some sunlight gets in, and what does get in kind of stays, because it's not allowed to escape like it might be on the Earth. So this is like a runaway greenhouse effect. Very bad. Okay, now let me go back over here. Boom. Okay, now that was the end of my little lecture here, because I'm running out of time on this. I'm going to stop this and start another recording on basically Mars, and then I'll also put up some problems for you to look at today. Not problems, some questions. And if I don't talk to you again, I will see you hopefully a week from today in class. Have a really good Thanksgiving, and you'll see me again in a little bit when I finish up the next video on Mars.